So now that we are sort of ready for the next one, I think I will show you something about how can we make the turtle stop as a be a little more clever, knowing how far round in the circle it has actually gotten, so we make sure that the shape gets closed and we don't have ugly ends. And it's also more like a principle to actually show how it's done. So I'm going to do a new block that I'm going to call poly for polygon as usual, and then I will call it stop. And we need a side length, and we will need an angle. And I say okay. And I will make the variables side and angle. Right. So for this, I need to introduce something new. Under the variables category here, we have, a gray one that's standing out a little. And you can see we have loads of things we can do, and we'll sort of get into some of them step by step. But for now, I want to make what's called an internal value here. So it's called a script variable, and this variable is sort of like a little guy that is accessible, but only in this case in the Polystop block, because it's not about what other global values we have. The global values are accessible to all the blocks, and the global values, you can see them here if global values exist, and I do have one because I use them for the icons. You can see in this case I have a global value called angle, and they can be shown on the stage, which can be very nice to sort of keep track of things. But for now, I'm going back to the local value inside this little world, inside the Polystop. And what I do need is I want one value called turn, because I want to keep track of how far has my turtle traveled. And I need another one I call check, because we need to check, how far have you gotten in relation to the 360 degrees idea of that being correct. I mean, filling out a whole circle, traveling a full turn. So I start by setting it, and in this case, I can do the set. I can actually do it 2 times. And now this variable exists in this little world. So I'm setting the turn to 0, and I am setting the check to something not 0, because what I want to happen is that we use something called the modulo to keep track of how far we are. And that modulo is going to be 0 when it's done. So when it's 0, it will stop. So we need to start it with something not 0. Right. So now I need a repeat loop. So the goal of this is to make a loop that will automatically stop when it has reached 360 degrees. So we don't have to keep sort of tabs on how far and whether the angles align or not. So in this case, I can use a repeat. I don't want to use a repeat with a specific number. I need a different variation of the repeat. In this case, I want a repeat that has the condition. And you can see under operators that you have these kind of triangular ended ones. And if I right click one, I'll just have a formal look and see. And you can see if direction equals 0, then do this. Well, it was not very helpful, but so this is equals something. So what I can do is I can say repeat this block until our check value is 0. And I will come back to why this is the case. But for now, we can just do the usual. We start moving our mouse. We use the side length as we've done so many times. And not surprisingly, we turn it. And we turn by our angle. Nice. So this is not new. What's new now is that I'm going to set the turn again. This means that inside the loop, I'm going to set the turn angle to, and then I want to add these two values. So I can put the add block into here, and then I am going to say turn plus whatever angle. So we started our turn by being 0, and then we say plus turn plus the angle into the new turn value. So this one will sort of increase and increment the value. So now we need something that can check whether or not the turn value has reached 360. And the way we can do this is by using a little new guy called the modulo. And modulo is sort of checking. We give it a given number, and then it checks whether there is a remainder when we do a division. So in this case, I can say if I divide the turn value with 360, and then explicitly it will become 0 when there is no remainder, which means then we have reached 360. So this is a way to actually make a loop, construct a loop, and we can of course use, sometimes we need more than one convolution, more than one round, but we can get back to that. For now, this should work and actually generate a very, usual circle as usual. But if this loop works, then it will automatically stop after having reached a full circle. So you remember, I am not saying, I know it should be 6. So if I say my side now is 100 and my angle is, say, 60, ta-da! This one now knows that we increment our angle and then it gets 360, and then the modulo will stop it because then the remainder is 0, and we can check that remainder. That's what we're doing all the time. So that is a way to check, have we reached a full 360 round. So this is our first little building block in the for the next round.